My name is Katharina and I'm a software engineer at Dynatrace. I have started my professional career as a software developer and I'm now emerging into the world of platform engineering. I'm taking this step because I really enjoy working with the cloud-native landscape and utilizing the tools it provides for contributing to our internal developer platform. I am passionate about automating deployments and infrastructure, about speeding up pipelines, and I really do care about security and observability. In short, I just like to improve the everyday productivity and happiness of our developers and help them in their day-to-day life. But as a former software developer, I'm totally aware that many developers do not share the passion for those tasks around shipping a product to and running it in production with me. And this is totally fine. This is one of the reasons why we are trying to build a platform that takes away all those tasks from them and centralize it in an internal developer platform. But what is this internal developer platform, or in short, IDP, that I'm mentioning all the time actually? And to explain that, I want you to travel back in time together with me. And we are going to travel back a long time. Well, not to the dinosaur area, but to the time before Agile was actually a thing in software companies. And in this time, let me introduce you to Alex. Alex is a software developer working in a development team, and they have just finished an application they have been working on. And they want to publish this application to production. But in that time, remember, we're many years back, before Agile was actually a thing, they could not simply go ahead and say, hey, I'm pushing this to production now. They had to go to the testing team first and let the tester verify if everything is working as intended, if there are any bugs in the software, and then they would get it back together with some feedback. In the best case, everything is all right, no bugs were found, and they could move on. But probably we're all software developers, so we all know that probably there were some bugs in the software. So they had to fix it, repeat this cycle, pass it on to the tester, get feedback again. And in the worst case, they even had to do this multiple times. Then in very big companies, they might even had a separate build team. So they would need to pass their application onto a builder, get an artifact built out of it, get it back. But Alex is lucky, they could do it themselves. And as a next step, they are good to go to production now, right? But still, they cannot do it themselves. They need to pass their application over to operations, who will then publish it to production. Doesn't look too bad, right, when looking at it. But still, I'm very happy that I didn't have to work in that time. And the biggest reason for that is inefficiency. If you think about it, it just takes really, really long from the time where you finish an application until you can publish it to production. Some colleagues of mine even told me sometimes it felt like ages until you get an application built and deployed. And also, bugs were found really late in the life cycle, because the whole implementation was already done, and then only the testing and fixing would happen, which was very hard for exactly that reason. So, luckily, people started to recognize this is a problem. And what they did is they introduced Agile development. And Agile is about much more things that I'm mentioning here, but I'm just mentioning the things important for the workflow of Alex's application now. So what people did first is they moved the testing team into the development team. So one external dependency was gone, and people could now start to test their features directly while they were implementing them. And this was a great improvement already. Bugs were found much earlier, and it was much easier to fix them for exactly that reason. If there was a build team, it would be moved into the development team as well, and containerization and tools like Docker helped a lot with that. And I think you can guess the next logical step, operations would be moved into the development team as well. So now we have one team that doesn't have any external dependencies, and they can really live by the principle, you build it, you run it. So they are now owning their application from the very first line of code over keeping it secure, keeping it updated, testing it, making sure no vulnerabilities are in there, building it, deploying it, and in the end also observing it and making sure it runs stable in production. And if they now write a new application, they can go ahead and publish directly to production. With one little exception. we still need an operations or infrastructure team. Because if this team needs infrastructure, like for example, a database, a Kubernetes cluster, any other cloud service, in many companies, they still have to request it from the external infrastructure team, wait a bit and get it. And this is actually the situation we have in many companies right now. We have one team that does operations, infrastructure, and so on. And we have many teams that live by the principle, you own it, you run it. So let's take a look at this at a bit bigger scale. With 4 teams now. And all of these teams really live by the principle, you write the first line of code and you run and observe your application in production. And we also have operations, as mentioned. And this principle for these teams now means they need to have a lot of knowledge, actually, because they need to know about the tools for writing code and testing, about security tools, about deployment tools, about CI tools, and many more I'm probably just forgetting right now in this situation. And now all of these teams, for example, do care about dependency updates. And the company might provide a tool to do dependency updates for them, but still each team needs to write their own configuration. So they go ahead, maybe 2 teams work together, but in the end you have, in this case, 3 persons coming up with a configuration for the dependency update tool. And in the end, you have 3 different solutions for the same problems, and it's really hard for people to switch teams or to help out in other teams with that situation. And this is one of the reasons why it is time to move on our workflow to platform engineering, in my opinion. And what platform engineering does, it simply takes an internal developer platform and puts it into the middle of all those teams. And then, instead of each of those 4 teams coming up with their own configuration for example, the dependency updater, one team, the platform engineering team or one of those, could come up with their configuration, put it in the platform, and all the others can consume it. And by that, we have one solution for one problem. All others can use it, and teams can even contribute back if they need it. And I know dependency updates is a very simple example in this case. But let's think it further. Let's think about publishing images for your applications. Think about deployments to Kubernetes, for example, or Google Cloud Run, or whichever service you're using. About observability, and about all those tasks that can be centralized and put away from developers to allow them to focus on writing code. And nice thing, we can also handle infrastructure provisioning via this platform. So our last dependencies to operations is gone as well, and we have fully self-sufficient teams by now. But why is this actually so useful? Why is it worth adding this extra layer of complexity between all our teams? And why do we need an internal developer platform? The biggest reason for that is less cognitive load. Because by centralizing those tasks and also simplifying them for developers, you reduce the cognitive load of developers a lot. I'm not saying that they are not capable of doing all that. I know that there are persons that know about all those steps from writing code, building it, publishing it, and so on, but it's simply not necessary anymore. And it allows those persons to really focus on writing code, on getting features out, on fixing bugs faster, and so on. So the less cognitive load developers need to spend on administrative tasks like publishing software, the more focus they can put on developing, which is actually the thing they are here for. The next thing is autonomy. Having an internal developer platform allows you to do things without waiting for others. Remember Alex's example? They passed on the artifact to operations and had to wait a few days because operations was busy. With an internal developer platform, they can deploy themselves, and they can also get the infrastructure for their applications themselves. And if somebody in your company needs a database, they should be able to get it on their own within a few minutes and with a few easy steps, no matter if they're an infrastructure admin or a Node.js developer, for example. It should just be easy. The next thing is unified solutions. I've already talked about this with the dependency updater example. But with an internal developer platform in the middle of all those teams, you can really make sure that you centralize solutions, that you unify, and you make it easy for people to switch topics, to switch teams, to help out others, because everybody is working in the same way. Also, a platform can provide standardized workflows. Because I want you to imagine the situation. You are starting in a new company and you should add a new microservice to the catalog, for example. A colleague will give you a repository with a sample microservice and maybe a link to some documentation or two. You take a look at the code, you dig through the repository, you find something that's not clear for you, you ask the colleague and probably can be ignored because because we had to do this fix because of that person and that situation and so on. Next, you dig through the documentation. There may be a few dead links in there, a few outdated things, and it takes you up to a week or maybe even more until you can get started with your microservice. And this is not something I came up with. This is something that really happened to me in previous companies. And I'm sure some of you will know that situation as well. So with a standardized workflow, you can provide a golden path for developers to create, for example, microservices. You will have that path easily implemented and documented, and people can just use it to instantiate and get started with their microservice within a few hours instead of a few days. And last but not least, a platform can provide a neat service catalog. This means it's a similar situation as with the standardized workflows. Because if you now have a service in your company, what I have been doing in the past was always going to the Git repository, checking the Git history, and then somehow finding out the owning team. But it was always a bit annoying and not always up to date. And with a neat service catalog on top of your platform, you can have a collective of information about your services. And then a developer can simply go to that catalog, can search for a service, and they will see the owner, they will see for example, where it is running. Is it running in staging, in production, maybe only staging and hardening? They will see a build and all other necessary information that is custom to your company. Cool. So how do we get all of this? And how do we get it without ending up in a situation like this? This is a Reddit post on our DevOps, and it basically says, we have spent months building this platform. Developers hate it. Help me understand why. And there has been quite some active discussion around it, and it has also been cross-posted with some more discussion. And I've read through it, and in my opinion, the biggest reason for this situation is that the platform engineers in this case simply went ahead, built a platform, threw in everything that they found is cool, and then gave it to the developers and said, hey, use it, we're done, this is now the thing you should use. And as you can imagine, this didn't work. So how do you avoid this situation, and how do you build a platform that your developers actually want to use? The answer, unfortunately, is it depends. It really depends on your company, because a platform is such a big part of your company and of the way you're working. And you really need to find your very own use cases, your very own stakeholders and requirements. If you're a small company, or if you're a company that is just starting out, you might be able to use a platform as a service. So basically a ready-made platform that you can just buy. Because what these platforms are doing is they are hiding a huge amount of complexity from you by making it opinionated. Because that's the only way to hide complexity, by opinionating it and then giving it to the end user. And this is nice. If you don't have anything yet, you can choose a platform, you can stick to it, and you can adjust your working model to it. But if you are already a bigger company, if you already have the processes in your company, it is really important to find out who your stakeholders are. It is, of course, the developers, but it's so much more than the obvious ones. It's the architects, the product owners, the team leads, management, and depending on your organization, maybe even more of them. So you need to find out what they want. You need to give them the chance to get their requirements in and then start implementing from there. The next point is you need to have a clear mission. So you need to know which problems you want to solve with your platform, how do you want to solve them, and which problems do you not want to solve with your platform. Kind of fits into you need to know your use cases thing. Designing for a good user experience is very important. And with design, I'm not talking about having a pretty UI. I mean, of course, that's important as well. But I'm really talking about designing for user experience. This means you need to know which components will you have, how will the components interact with each other, and how will the users outside of the platform interact with your platform. I've read a very nice term recently, which is RTFM, so read the effing manual-driven design, that a few tools are utilizing right now. So what they do is they provide a huge manual, and you need to read the manual before you can use the tool. But by building a good platform, you need to do it the other way around. You need to have design constraints and signifiers to lead the user by design onto your platform. And then the manual is just an addition to that if they need any further information. Next, it is very important to start small. Why don't we utilize the things we've learned from software development in the past few years also to platform engineering? It is really important that we start small and prioritize the quality of our features over the quantity of our features. This means really have an MVP, a minimum viable product, share this with some early adopters, get feedback on this, and then only make it available to the broader audience and grow from there in means of users and also of features. And last but not least, make your platform observable. This is on the one hand very important for troubleshooting. You will probably face some problems in the future with your platform, and that's totally fine. But by making it observable, you make it much easier to troubleshoot them and to fix them faster. And in addition to that, by making your platform observable, you can measure the success of your platform. Like, for example, how many users are using it? Are there returning users? How many one-time users do I have? And what can I do to make them return again? And also, you can utilize things that already exist here again. For example, in the DevOps world, there are the drawer metrics that tell you about the performance of your deployments, and you can simply reuse them and use them in your platform again to measure how much faster developers can deploy applications by using your platform or without using your platform. So all of those points, finding your own needs, having a clear mission, designing for a good user experience, starting small and observing it, actually sum up to one statement. You need to treat your internal developer platform as a product. And if I want you to remember one thing from my presentation, it is this. Because I know it's only internal. Your consumers are the developers in your company. But still, you need to build a great product for them that makes them happy to work with and also to make them more productive during their day-to-day work, for them to get features and bug fixes out faster. Okay. That was a lot of theory now. So let's come back to Alex. Alex has written an application again. And let's take a look on how Alex would publish this application with a sample implementation of a platform. As said, probably no two platforms are the same. And I just put a very abstracted view here with my favorite tools to give you some starting points if you want to have them. But nothing is set in stone here, so you can really adjust to your own needs. So finally, back to Alex. Alex is done writing the application and the tests, of course. And the next step that Alex would take is building an image out of this. My favorite tool is GitHub Actions. Alex simply goes ahead, writes a YAML file, and builds an image and pushes this one through a registry. Next, they need to define how the application they want to deploy looks like. And so in here, we have an application with the name Hello World. It is of the type web service. It uses the image we have published in the previous step, is exposing port 8080. Oh, and I didn't tell you yet, but it has a database of size medium, whatever that means. Medium is then translated by the platform engineers into some actual values. And this YAML with, I didn't count, but probably 20 lines, is all that Alex needs to write to deploy their application. Because it's all that Alex probably cares about. If there would be more things like databases, they could add more traits in the bottom. If there are any custom properties, they could add it up there. But this is really the minimum configuration. And the tool that makes this possible in the cloud-native world is the Open Application Model. It is a specification for standardizing the way applications are described and deployed. Okay, so Alex has now published an image, wrote the specification. The next step is to store the specification somewhere, so that the platform knows what the desired state of the things to deploy actually is. And I think in this step, there's no way around using Git for storing that specification. So what Alex did by now, pushing an image, writing a spec, pushing it to Git, And that's it for Alex. That's all the step they need to do to publish their application. And from now on, the platform will take over. And what it will do, it will sync the desired state from the Git repository. And for this, I like using Argo CD, but you could also use Flux CD, for example, to sync the desired state in your Git repository to a Kubernetes cluster that will then, in the end, apply your desired state to the actual world. I already spoiled this one. I really like, and I think all the platform engineers I know are using Kubernetes, but we are also using Crossplane in addition to that, so that we are also able to apply things outside of our Kubernetes cluster to, for example, AWS, Google Cloud, or any custom thing you want. And by that, the last step is to watch or observe the application. So Alex will get an automated dashboard out of this, and also alerts, so that they don't have to actively watch the dashboard. And for this, my obvious tool of choice is Dynatrace, but I stick to the open source world here. So what you can use, for example, is Grafana, together with an open telemetry collector, and Captain for automatically getting Doro metrics out of this. And that's it. Our deployment is done. Time to celebrate. And that's also it with my presentation. Thanks a lot for listening. If you have any questions or want to reach out to me, you can do that via LinkedIn or my website. I would be happy to hear from you. Thank you.